This video will demonstrate and explain the system we previously deployed in the production environment. The original system interface is set to Chinese, and we have not yet converted it into English. Therefore, the text in blue on a black background in the video provides translations of important interface information. We will demonstrate our system operations using a test user. First, we log in to check if the test user exists. Upon searching, we find that the user does not exist, so we proceed to register the test user. After submitting the registration information, the system automatically generates the user's user meta and then enters the system. We provide a simple user interface consisting of three main areas. The first is the space utilization viewing area, which shows the capacity distribution and specific usage of the current working folder. Below this area is the running messages display area, which primarily provides interaction logs for the poor consensus mechanism. The most important area is the file information display area, which shows specific file and folder views and allows for operations. Two icons in the bottom right corner enable switching between icon view and list view. The working path display area is in the top left corner of the system interface. Clicking the text allows direct switching of the working path. The top right corner contains the search and system exit buttons. Clicking the search icon brings up the search function window. Clicking the system exit icon prompts a confirmation operation. By clicking the plus icon on the operation interface, users can choose to upload files or create new folders. Now, we create a folder named Documents. Every file system update operation triggers an update to the user meta to ensure it records the latest state of user file information. As shown in the message log in the video, before updating, some data blocks need to be deleted, and then the user meta is restored. According to the poor consensus mechanism, the first beginner node is randomly selected, and in this storage operation, node N2 is chosen. The system automatically hands over data block 0 to node N2 for storage and instructs node N2 to initiate the election of the next beginner node. Through the poor mechanism, node N1 becomes the next beginner, so data block 1 is stored on node N1, and a new round of elections begins. This process continues until the user meta storage is complete. Next, we create another folder named Images. We will perform storage operations with a text file and an image file. As before, the creation triggers a user meta update. We open the local file system, where two folders have been prepared in advance for the demonstration. The first folder contains the two original files needed for the demonstration. The second folder is an empty folder set as our download path. In the original data folder, a text file and an image file are provided. Opening the text file reveals it describes partial ownership of our system. The image file is the cover page of the documentation used in previous competitions. We now store the document file in our system. It can be seen that we have added a lock icon to the file icon, indicating that it is an encrypted file. The specific encryption process can be found in our paper. We then switch to the Images folder to store the image file. It can be seen that the system is storing the file, and the running messages area shows that the interaction logs of this storage process are continuously updated. Once the file storage is complete, a user meta update operation is triggered, and the user meta is reloaded. We then exit the system and switch to node N2. After logging in, we can see that the user meta parsing maintains the latest records after the last operation. We search for the image file and view all the test user's file and folder information. First, we download the document file and compare its content to ensure consistency. We open the local file system and the downloaded file. The content is consistent with the previous version. Similarly, we download the image file for inspection. The content is also consistent. Next, we demonstrate deleting a file and briefly outline the deletion process. Because our system ensures that the plaintext data and the hash pointers between data blocks only appear on the client side, before deletion, the encrypted file must be downloaded locally to parse the correct pointers between data blocks. This allows the entire data chain to be restored, enabling the node to execute the deletion operation. Deletion also triggers user meta updates and reloads. Deleting an empty folder is much simpler than deleting file blocks. It only requires updating and reloading the user meta. Finally, we search and find that the user's file and folder information now only contains a document file and folder. This concludes the main user operation demonstration. Thank you for watching.